welcome everyone to this presentation. It's good to see you all, and before we begin the presentation, I would like to inform you all that this session is being recorded and will be posted on our website later. Today, we'll hear more about an assignment that was conducted to electrify a melting pot for plastic in Senegal with our local partner, Niafrang's Venner, or Friends of Niafrang, and their project Waste at Work. To put it simple, they clean up plastic waste from the nature and the beach and recycle it to paving bricks. And EVB has been cooperating with this project for almost 3 years now, and we have previously contributed with expertise in machinery and solar power systems. This Easter, volunteers Jan and Katrine traveled to Senegal to execute their fieldwork. Katrine has been following the project for a few years now, acted as an advisor for the past 6 months, and Jan was recruited specifically to work on electrifying their melting pot. So we are looking forward to hear more about that, and there will be time for questions at the end. So the floor is yours, Jan.
Thank you very much. Okay, then I start. My name is Jan Eiterström. I am going to talk about the electrification of the melting pot in the Caravana Plastic, the factory in Senegal, and talking about preparation, the field trip, and the work afterward. And the picture here is, as you obviously can see, it's not on the preparation, it's on the field trip, actually. So this is how I see Africa. It's yellow, it's sand and sun. Before I go further, I would like to thank Hilde for her hospitality. We was living at her guest house. And thank you for the Waste at Work organization, people at the factory, management. Everyone was very lovely. And I say thank you to Katrine, who has been a project leader on this Work at Waste project a couple of years. It was very good to have you with me on this field trip and also in the preparation.
You muted yourself, Jan.
So a little bit about the organization. As Elisa said, the project owner is Niafrang's Venner. He represented by Hilde Hus Hansen. The project's manager has been Katrine Osjær Garnes. And also you have a group in Senegal, of course, called Waste at Work. That is the organization that do all the work with the collection, production, and sales of finished product. The scope of this project, or terms of reference, was assisting in electrifying the melting pot at the Caravana Plastic factory. And the benefits from this project is that it gives more sustainability because we're using electricity instead of gas for heating. We don't have to transport the the gas, and it's giving reduced cost on the product as well, because there is already a solar cell system, so the power is free. Also, we can have some improved process control, since we can control the temperature much better.
You muted again.
Okay, now I know what I'm doing. What I'm doing wrong. Okay, a little bit about myself. The motivation for me to be in this project is that I can contribute to the huge plastic waste problem, and help a little bit to solve it by participating in this project. I can make use of my technical knowledge, of course, and it also give me a lot of personal development. My background, I'm a mechanical engineer. I've been working a decade with product development on electric heaters. I have been working as maintenance manager in an aluminum smelter, and have been working with equipment where you are crushing and mixing and forming raw material into products. And I also been done some project management, and now and then do some process and equipment improvement in my job. I've looked at the situation at the factory, and I have been in contact with Hilde, Katrine. I've been reading the reports from earlier phases, and before I started to look at electrification, I found out that, okay, this is the situation. We have a gas-fired melting pot. It's about 15 to 17 kilowatts, actually, this gas burner. The production on one batch is 40 tiles, and the tile consists of 0.6 kilogram plastic and 1.8 kilogram sand. It's difficult to control the melting temperature. There is no thermostat on this one. And the good thing is that there is already a solar system installed at the factory, and it's not fully utilized as it wasn't before I went there. I found out that the actual power I could take from it, if I used 230 volts, is about 6 kilowatts. There have also been done some experiments with electrical hot plates and a small pot, but without any succeed. So a little bit about what the goals should be with this project. It should, of course, be possible to produce tiles with solar energy only. And I would also like to be able to have a backup system that we still could use the gas-fired pot if we had some problems with the electrical one. Since we only have 6 kilowatt power, and the gas burner on the existing pot is giving 15 kilowatts. Then we have to look at insulation to conserve the energy. One of the goals was to use proven technology, and that it should be possible to regulate the temperature. And of course, easy to operate, maintain, and repair. And also, as much as possible, be able to get spare parts locally, and at least that they are not very expensive. And there should be no risk of personal injury, either concerning electricity or from the melting process itself, heat. And one of the goals should be that when we was leaving the site, the personnel should get training in operating and maintaining the equipment. So as a preparation, I started to look at some standard products to use to test. And I decided to go for those 3 units to test on. Then we could test if it was possible to use induction heating, and if it was possible to use a standard hot plate. But I also found out, okay, there are some tubular heating elements with the cable and plug that is meant for starting barbecues. And I found out, okay, I tried this also. And I later found out that it was actually a good heating system. I tried to make, when I tested, I tried to use the same power. So all 3 systems are 2 kilowatts. So therefore I had to use 4 barbecue starters. They are relatively low price. They are easy to buy. They are they are complete units. You don't need to do some product development work on the heating units itself. And I also built a pot for the test. And my thought was that the bottom should be thick. And of course, it had to be steel, because if I was going to try induction, it could not be stainless steel or aluminium. And this wall is actually a pipe that is made in 2mm stainless steel. And there are some adjustable feet, so I can place the heating sources directly against the bottom plate. So here is actually the result when it comes to heating and heat distribution. And what I found out was that the induction plate, it had some advantages. You have everything in one unit. You can regulate power. And you don't need any direct contact, because you are making heat by frequency. What I found out is that it was heating on a very concentrated spot. So it went up to 300 degrees in only 6-7 minutes. And also you got reflection down to the induction plate, and a couple of times it tripped because of high temperature. So I found that it was not good for the electronic in the long term to use a standard induction plate. And it's also a little bit difficult to scale up to the pots, melting pots that we have on the factory. Standard hot plates, a little bit better heating distribution here. And same here, you have everything in one unit, and you also have a thermostat on this one. But I found out that the bottom plate on the pot, it wrapped. So you got the air gap between the hot plate and the pot itself. And you get a lot of heat loss. And also you don't have any insulation under the heating element. So you will get some heat loss in that direction too. So then you have the tubular heating elements. I made some heat distribution plates, as you can see. This one this gives a very good heat distribution because you have direct contacts with between the element and the bottom plate, and it's also kind of flexible to if you have some warping in the bottom plates. Those, if you have more elements, they will just follow the change of the form. It's also possible to insulate under, and that is what I have done later. Easy to scale up. You can put as many as you want to get which power you want. But that, of course, give a disadvantage with the many cables. And you also need an external temperature control box compared to the other two that you have everything in one unit. So I also tested insulation because I found that it was important to see what the effect was. And what I found was that insulating the lid gives a lot more effect than only insulating the walls. If you have insulation on the walls and on the lid in combination, that gives the best result. And if, of course, if you can have some reflective material also, so the heat is reflected back into the melted plastic, that will also give some good effect. I did a couple of melting tests. I did it outdoors, and as you can see, it's still winter in Norway when I'm doing the test. I used 3.5 kilograms. I used, as you can see, insulated walls and lids. And I did two tests on different temperatures, and found out that both tests gave good results on the quality on the plastic. But of course, if you the more you're increasing the temperature, the shorter time is used for melting the plast. When I did it on this test, the plastic is not completely liquid. It's more like a dough. I also, because we need an external thermostat box, I built one. This is a standard circuit breaker box. So, and all the products in it is modular. So I have a ground fault circuit breaker, and I have a contactor that distributes the power to 3 outlets. Since we are going to use the 3 phases, we have to do that. And a thermostat with a sensor that is mounted under the bottom of the pot. For the pot that we was going to rebuild on the factory, as I made some, I bought some elements for that. 6 800 watt element and 1 500 watt in the middle, and made the distribution plates, as you can see on the picture on the left. They have 2 functions. One is to hold the elements in place, and the other is to distribute the spread heat onto the bottom plate. Also, I was very lucky that I was involved in the status meetings that Waste at Work had every week. So I was able to get to say hello to people on the factory, and could start to communicate with them and have discussions. And we found out that okay, we are not sure which pot we are going to rebuild, but we decided that on the factory there was they had to source a 5 millimeter plate for rebuilding the bottom. And they also checked that the local welder, which is actually working on the factory, that he had the equipment he needed for cutting and welding in a new bottom plate. And they also assigned an electrician to install a new 3-phase outlet. It had to be with 5 pins, so we could use 230 volt elements in all the 3 phases. So that's good. And now we are starting with the field trip. After 2-3 days of traveling, some waiting in Gambia to get the visa, and then we came to the factory. And I just want to say a little bit about luggage when you're planning some practical work. I was thinking, okay, I don't need more than 1 suitcase and maybe a hand luggage. But when I was finished, I had packed almost 60 kilogram of equipment and tools. So I had to use even the PC bag that you can stow under the seat in front of you. And it was also packed with 8.5 kilograms. So I had a considerably lot of equipment with me. So don't underestimate what you really need when you're going for a field trip like this, that you're going to install something. Yes, this is the first day. I was introduced to the people on the factory. They have already, the electrician that they have assigned was already in place. He used 2 hours and to install the 3-phase outlet. Gilbert, the welder, which is standing in the T-shirt. I think it says smile on the T-shirt. He was doing the cutting and welding and replacing the bottom plate. And I could start assembling the three-phase system and tested against the solar system to see that the solar system was capable to handle those effects. And that worked very, very well. So we got a very good start the first day. And then it's continued. Day 2 and 3. This is the installation of the heating elements, the thermostat, the control box, and the installation of the elements. And here we can see on the picture on the left-hand side, you can see the issue you have with this kind of solution. You get a lot of cables and outlets, and what we decided to do, and we actually talked about that before we went down, me and Katrine, that we should build a platform to protect the cables, but we have a look on that when we come down. So me and Katrine, we designed the platform. Katrine and her boyfriend was purchasing material, and Gilbert was welding the platform. So this is the result. It was very good. So this was the first day of testing. Now it's starting to get exciting. We prepared both the electrical pot and the gas-fired one, so we couldn't compare. We filled both pots with the same amount and type of material, and we found quite early out that the gas-fired pot was faster, much faster. And that was as expected, because you have a lot more power on the gas burner than you have on the heating elements. We started with low temperature, and later on we increased the temperature, but we actually found out that, okay, we didn't reach enough temperature on the electrical fired pot. You see the maximum temperature is about 350 degrees Celsius, and we obviously needed more. So after the test, I relocated this thermostat sensor a little bit, so we could reach higher temperature for the next test. But also what I found out, and I have outlined with yellow, is that the plastic itself has to be completely liquid before sand is possible to mix in. So that says a little bit about the process, that the process itself is not good, because you get the temperature that gives self-ignition, and that compromises the quality, and it's a safety issue also. So, but we can go on the next slide, page, where we did the second test. On this one, we used we had produced a lid, and it's actually insulated the lid, so we used that from the start. We started with a higher temperature, in average 400 degrees on the bottom plate. And we only used HDPE to see if that helped, because they have experienced that HDPE is easier in a way to melt in a pot. And also the same here as with the gas-fired pot. We observed some self-ignition. It's not much, though, but you see the flames in the melted plastic on the picture on the right-hand side. But we was able to produce tiles. 26 tiles was produced, and the quality was as expected. So that was good. So that is the result from the second test. The third test, we reduced the temperature a little bit to see if we could avoid self-ignition. And we did not see any self-ignition. And we was able also here to produce tiles, but it was very difficult to, it was very hard to mix in sand, and it was very hard to form the tiles. So, but we produced the tiles. So the conclusion here is that yes, you need quite high temperature on the plastic to be able to mix in sand and also to form tiles. So that is a challenge because you are very close to the self-ignition temperature. And that is one of the major issue, I will say, that the process is not maybe the best practice in the world when it comes to making plastic and sand tiles. And I also see if you put too much plastic in the pot, you actually get the crust on the top of the melted plastic. So it's hot in the bottom and it's not so hot in the top. So the conclusion is that there is a limit on how much plastic you can put in the pot. And yeah, also one issue why the LDPE is not so easy to melt is it's because some of the LDPE contain some water drops, and water needs a lot of energy to evaporate. So possible solutions could be to experience with temperature, to find a balance between viscosity and avoiding self-ignition, and also reducing the size of the batch to get more uniform temperature in the melted plastic. Some thoughts about the HC. There is a lot of gases, both from the melting process and also the forming. And I saw there was a very variation in use of gas mask. Most of the people was using gas masks and protection gear like gloves, and there is a procedure on that, and it was made some extra effort when me and Katrine was on the site. She did a lot of good work to make them to use the procedure. and make a system to store and have names on each masks and everything. Yes, about the insulated lid, that actually adds a new risk because we're closing in hot gases, and there is a risk that when you lift the lid off the pot, it can explode in a way that you can get combustion. So we have implemented a procedure to how to lift off the lid to eliminate the risk of that. Actually, the latest solution will, and I think that is going to be built now, it's to put a rope on the lid, hang it under the roof, and put the rope another place in the factory, so you can actually lift the lid remotely. And when I was there was Katrine was working on. She had designed and had built a ventilation hood over the forming table, so that was also in progress. And I think that was finished after I left. We also did some training. Both the manager and workers at the factory, they was participating with me when I was installing the equipment, and then they learned from that. And they was very interested and had comments and had suggestions, and it was a very good experience. That and I made a operation and maintenance manual. This has been handed over to the team on the factory, and we also held a theoretical training session based on the operation and maintenance manual. And one of the main things was to focus on electrical hazards, because this is electric equipment and it should be maintained well, so we don't get any problem with that. Yes, this is the status after I have left. They have produced 15, 16, 17 batches on the new electrified pot. They are not using the gas-fired melting pot anymore. That's good. So the goal is achieved. We are now producing only on solar power. As per 8th of May, 24 to 28 tiles are produced per batch, but I want to go up to 30, 35. Hope to do that. They use mostly HDPE, which is gives a little bit problem with LDPE, because they are using less of that. So maybe they have to use the gas-fired pot now and then to use some of the LDPE plastic. But maybe they also, that was my suggestion, that they could produce 2 smaller batches per day to see if they are able to use more of the LDPE. And actually yesterday I got the feedback that yesterday they managed to produce 40 tiles in the electrified pot. So that was very good feedback. This is the last slide, and it's only some thoughts about what I think Engineers Without Borders should focus on when it comes to further activities and projects to develop, improve the system for using electricity. And I think the main thing is that we should look at the process itself, because I don't think really using a heated pot to melt plastic and manually mix in sand is a very good process, because you are getting very close to self-ignition temperature, which gives HSE issues, and you compromise the quality on the plastic. So I think if we could find a process that is possible to implement in small factories like the caravan, which where the temperature can be lowered, let's say 50-100 degrees. So we are way below the self-ignition temperature. Then we will reduce HSE risks. We get less toxic gases, and we eliminate the explosion risk. And we get less energy consumption. And also we can reduce the production time if we can melt the plastic on a lower temperature. And of course, the quality of the tiles gets better. What we could do is to develop a heating element in cooperation with a manufacturer of heating elements, so that you get one unit that you can assemble under existing pot with just one cable and maybe an external control box, instead of all the heating element with one cable on each heating element. So it gets more streamlined. You could also develop that. Also had to be done together with a manufacturing company, a tailored heater plate, and combined with a pot that have a machined bottom plate, so that we actually have two units. We have a hot plate, and we have a melting pot. That could also be a good solution. But I think I believe that looking on the process itself could be a better idea to get better production. So that's everything from me.
Thank you so much, Jan. Really great work. Thank you. Now I was wondering if Hilde, if you would like to say something from Nya Franksvenner. If you're here.
Yes, I would like to thank Jan for this presentation. And as I have told to you people in the Engineers Without Borders already, it has been one kind of life at the factory before Jan came and one life after, because it's really a milestone that we can produce only by solar. We have that is a great thing we have achieved because of him. And I see he has already, although we have a lot of problems, technical problems and other problems, because it's a many-faceted project. But we are so happy that Jan has been here, and I am very excited to hear more about this thoughts they have of a better melting process, because we understand we can't have this. It will not be sustainable production or project if we cannot produce bigger volumes, and also we have to solve the mystery that surrounds selling and marketing. But thank you so much, Jan, and we hope you will be with us in some way or another for the future. At the same time, I want to thank Katrine, because she has been here for a long time, and these two people have been absolutely, unnværlige. They have been. It would not be where we are without these two people. So thank you.
Thank you, Hilde. And now, Jan, if you could please press stop sharing. You can see more people, and it's open to questions if anyone, or comments. Francisco.
Yeah. Hello. Nice to meet you, Jan. Hi, Katrine. Hi, everybody. Fantastic project. Very well done. I'm impressed. Very, very good. Thank you very much. And thank you for a very good presentation. Let me lower my hand here if I can. Yeah, there. I have a question, or a couple of questions. Regarding the HSE issues, the gases emitted in the pot. Do you have any thoughts? So whether the volume of the pot itself under the, let's see, the atmospheric pressure, or more or less just a little bit higher, will the gas, with the explosion of the gas, be such a magnitude that could actually be a major concern, or will it most likely just produce a flame if it goes in self-ignition? I don't know if I explain my question.
Yes.
Whether it will be just a flame, like when we light a gas burner in a grill, zoom, that it has a flame, or will actually be an explosion that may actually harm people.
I observed that as we had a combustion inside the pot with the lid on, but at least the one I observed, it was like that the lid was lifted 2 or 3 centimeters, and it was not that kind of explosion that the plastic came out, or nothing near that. But of course, I'm not 100% sure if we can get into that situation. So at least before we know that, we need to be very careful with the procedure when they're lifting the lid. And therefore, the solution will be, they had a meeting on the factory yesterday, actually. So I think they will start to install this rope system, so they can stand 5, 6, 7 meters away from the pot and just pull the rope and lift the lid straight up. The lid is very light. It's weighing about 2 kilograms, so it's not a very heavy lid.
But then, are they waiting on? I know they are not waiting, because they melt the plastic and they needed to have it in a liquid form in order to process it, as far as I understood. Because we have another project where they produce a dough, not melting, but they don't need to reach the melting point, but just the dough point. And then it can wait until the gases are, the whole thing is cooled down a little bit before lifting off the lid for accessing the melting plant. Right.
I think they have to, how the process is in short terms is they are putting in plast, they start heating, and then they heat until the plastic is melted and is in liquid form.
Right.
And then they are starting to mix sand.
All right. Thank you very much.
Yeah.
A fantastic project. Thank you. Congratulations.
Thank you. Thank you.
Thank you for that. We have a question in the chat, and I see you, Karl Ove. The question in the chat is from Trond. When a tile is worn out and need to be removed, what will happen to it? Will it be recycled again? And have you considered microplastics from the use of the tiles? Don't want to be too critical, but want to ask. So I know these are things we all have also been discussing. Katrine or Hilde, maybe you want to say something about it?
I can try. But, or Hilde, you want to start?
No, you start.
About first the microplastic, they have been doing some, how can I say, reports and testing in Norway from a company in Norway. Hilde can say more about that, but the first, like the results is that it's not a big issue. But of course we don't have tests that say something about long term, but how this tiles are out when it has been staying in the nature for like 20-30 years. But the first tiles that were produced have already been out in the ground for like 10 years almost. So there we cannot see any big issue with microplastic. And about recycling, we have discussed that a lot. Of course, we would like to try to find a solution for that. It is possible to, how can I say, melt again the tiles, take the tiles and put them in and melt them over again. But you need a lot of energy to do that, of course. But the biggest problem is that will we ever have the tiles back in the factory to do that? Or I don't think so. It looks like the tiles are very sustainable.
Yeah, Katrine's internet connection is not very good today, I think.
I'm sorry, I have a bad connection today. So maybe Hilde can take over from there.
Well, you mentioned most of the things we've been discussing, and we also discussed what do you call panting? What is that in English? I forgot. Panteordning.
Change.
Don't you hear me?
Yeah, recycle and return.
But return. Yeah, to offer them to have some money to give it, but when they don't use the tile anymore, they will bring it back to the factory and have some small money, because this is a principle that's already working very good with soft drinks and bottles, cans in Senegal. But it will be complicated, so we have put that aside for the time being, and maybe it's impossible. But we have done some tests. By Norconsult has done some preliminary tests, and we want to test the bricks a little bit more if it's possible. And the first test showed that it was not a lot of leaking of microplastic, but we will go more into that later.
Thank you. I hope that was sufficient answers to your questions, Trond. Karl Ove?
Thank you.
Okay, great.
Just a comment on the explosion problem. What's key is to keep the weight of the lid as low as possible, because then it will work as an overpressure protection. So you should never fix the lid to the pot, because then you could really run into a serious situation. So keep it as light as possible so it can lift up, and then you will have more a rapid burning or fire instead of an explosion.
Yes, it's actually made of 0.5 millimeter steel plate, so it's as light as it can be. And the form is not completely flat, so there will be some leakage between the side walls and the lid, and that is also good because you ventilate some of the overpressure at least.
But sorry.
And another comment, if you are thinking about extracting some of the gases, be aware that you could collect some places where you could have ignitable gases and clouds. So this is really tricky, and you should be careful to handle this problem really carefully.
Thank you.
But
yeah.
Can I just a little bit there? There is a ventilation pipe all the time at the top of the lid, right? So
no.
there is no actual pressure built up inside the casserole, even if the lid is pressed and locked or whatever. There is a ventilation pipe, so there is no pressure built up inside the casserole because the gases and the pressure will release through that, if I understood correctly.
That was done on the test pot, but we have not installed a ventilation pipe on the actual pot.
Thank you. Thank you.
Great. Thank you for your questions and comments. I see it's 4 o'clock right now. I do think we have time for one final question if anyone has anything.
I just have a final or a comment to Jan. Thank you very much for helping us in the Engineer Without Borders. And I'm from Sandnessjøen. I have passed your home place several times, so maybe we can meet once time. I have a cabin out an island outside, so I go up there in 2 weeks.
Oh, really? Where do you have the cabin?
Harøy.
Okay, I have a cabin on Dønna, so it's quite close.
That's great. Then you guys can meet up and talk more about the melting pot.
Yeah.
I will contact you, Jan.
That's great.
Thank you so much to Jan, Katrine, Hilde, the whole team in Senegal. You guys are fantastic, doing a great job. Thanks to everyone who came to see the presentation, or if you see it as a webinar on our homepage. And see you next time there's a digital presentation. Stay tuned. Bye, everyone.
Bye-bye.